Hello and welcome back to the second part of our Lightmap video. My name is Pascal Seifert and I'm the Technical Product Manager for VRED. And in this video I will deep dive a little bit more into the settings of the backlight and shadow module. So with VRED 2022 you can change from a vertex to a texture-based approach. It is possible to use your CPU and if you have a suitable GPU to use GPU ray tracing using NVIDIA optics. That is usually much faster than doing it on the CPU. Let's start simple in our scene with an ambient occlusion. In here we have some quality presets. These define the amount of samples used in the scene. A higher number of samples means a better quality but also longer calculation time. The minimum and maximum distance didn't change. So we use model units and we have 3 meters as a default how objects influence each other for the ambient occlusion. It is possible to use an indirect illumination, but I disabled that for now doing the ambient occlusion. Due to the fact that clones can have individual light maps, there is an option for share light maps for clones. This can be very useful if you have a scene like a car that is mirrored from one side to the other to share the light maps. In my scene I have some clones here, the screws. I want to have individual light maps for it, so I have to disable the option. It is also possible to save all the light maps as external references on disk and also don't inline them in the scene. I will explain that a little bit later in that video. In addition, you can use a denoising. That means usually you can have less samples and let the denoiser do the job. An option that says use existing resolution can be helpful if you have calculated some shadows already and made some tweaks to certain light maps and changed the size. When you do then a recalculation, it's using the texture size that was set already. For the texture resolution, it is possible to use a static value. I would not recommend that, as every single object in your scene will get the same resolution. It is more helpful to use a dynamic approach. In here, the texture density is the most important value. A value of 1000 pixels per meter means that you have 1 pixel per millimeter. Such a high value is only useful for small objects. If you have a scene like this, I want to recommend to stick to something between 200 and 500. That means we have 1 pixel per 2 millimeters. It is also possible to crop the minimum and the maximum resolution. If you want to make sure that each object gets a high enough texture, just choose a high value. The edge dilation we have talked about in the previous video. This is a 2 pixel overshoot around the island borders that we can later blend better. If your selection contains objects that don't have a UV set, you can automatically calculate a triplanar mapping and a layout for it. It is also possible to switch to unfold and layout, which is using the settings from the UV editor. In my scene, I have to make sure that I use the use existing UV set as I have unwrapped all my objects already. Okay, let's calculate some ambient occlusion shadows with exactly these settings for our scene. So in the Advanced tab, you can check for each object the light maps and also the settings. It is also possible to check that in the UV editor. You can simply turn off the wireframe and enable the show texture in the Visualize tab. I also want to show you how it looks like if you bake global illumination in the scene. We have some settings over here where you can also save your custom settings. So let's calculate some light and shadow with a high quality. We are using indirections as well. I will turn off the override material as I want to have the color bleeding from my objects on the ground, for example. I also want to disable the share Lightmaps for clones, the denoising, and the quality for the texel density I set a little bit lower again. I will activate that rectangular light and want to check with the GPU ray tracer what I can expect. This is exactly what I want to bake. GPU ray tracing, light and shadow high, and let's calculate them. Make sure that you deactivate the lights you have used in your scene after the calculation, otherwise the light is applied twice to your scene. Once it's baked and the other one is the real-time lighting. And this looks actually pretty good. So we get some nice color bleeding. As well as a really good quality with a medium tessellated mesh. It is also possible to use a CPU or GPU cluster for your shadow calculation. The cluster has to be enabled first. So in my case, I go to Rendering, Cluster, and I have added already an additional computation node with the IP. I then can start my GPU cluster, which has 8 RTX cards in it. So I'm currently connected via VPN to our cluster in the office, so this process takes a while. But once the data is transmitted, the calculation is pretty fast. Once I'm connected to the cluster and my scene is transferred, I can simply rebake everything. So let's quickly change the color of the light over here. So we see actually some difference afterwards. So you can see that my cluster and my GPUs are utilized quite good. So all GPUs have a utilization about 85 and 95%. And the shadow calculation takes only a few seconds. Now I'd like to show you what you can do with the Save Texture as external reference. So currently all the light maps I have calculated are stored with my VPB file, and my scene is about 20 megabytes. With that option, it is possible to outline textures into a separate folder on your disk and have a smaller VPB file, and all the textures on your disk that are loaded when you open the VPB file. So that keeps the file small. This is very helpful if you often save the scene and do some changes that are not related to your already calculated light maps. You can also use this approach for a variant switching later. So let me show how it works. In our scene, we have calculated some light maps already, and we want to outline these light maps into a separate folder. So there is an option in the select that can select all nodes with a texture bake. Therefore, you have to select the root node and then proceed the command. In the Advanced tab, you now see that there is a multi-selection, and this is actually the location we want to store the light maps later. So we go to File and then say Save Light Maps. We can navigate to a folder, and this was a GI bake. So select the folder, and now all light maps of my scene are stored in that folder. But they are still inlined in my scene. So if I want to, as you can see here in the path, they are just referring to that folder. If you want to outline them and have a much smaller file afterwards, you have to select the Use External Texture Reference. Now, when you save the file, you can see it is only 4.5 megabytes because all my textures are stored in here. Now let's create a variant of that. So I go into my bake settings and I want to calculate an ambient occlusion with some low settings. We choose cosine, we don't want the indirection. And now we enable the save texture as external reference and refer to our folder, Lightmap AO. If I now start my calculation, you can see all the textures are stored here. Windows can't preview them as we store the ambient occlusion in the alpha channel of the texture. So what can we do with these two folders of light maps? So in the Python API, there's a possibility to repath my light maps. And in my scene, I have created a variant set that loads either the GI bake or my ambient occlusion. So in my last example, I'd like to show you how you can bake some really interesting effects you usually have only in full GI, like caustics that are caused by glass or metal materials in your OpenGL scene. I have a very simple kernel box in front of me with a few objects in there, a chrome ball and also some glass objects, a prism and a lens. And when I activate ray tracing, there's currently not that much to see, but I have two additional lights in here, one for the ceiling, and there's also a smaller one over here in front of a glass prism. And what you can see in path tracing is that that light splits up in that glass prism already kind of bit, and here we can see some caustics, and also here at the ring is causing some caustics on the wall. So path tracing is not ideal for that kind of simulation, so it's better to have a photon mapping activated. This is supported with VRED 2022 as well. So while being in GPU ray tracing, we can go to photon tracing in the render settings and activate caustics and indirects. and you immediately see that you get a much better result, especially here where that light distributes in that glass prism quite a bit. It is also possible in the pre-computed illumination rendering to have a look at your photon distribution in the scene. I'm working with 1 million photons. That is quite good, or totally enough. If we higher that number, we can see that we maybe get finer and more detailed caustics, but it will also make a longer render time for that. So 1 million is totally fine. All the other settings I leave as default. In addition, for real-time rendering, we would then probably also activate the denoiser, and you can see that you immediately get some quite nice results immediately. So how to bake that? It is important that all your settings in the render settings are done already, so activating the photon mapping, etc., etc. And then we can simply open our bake light and shadow module. I can also disable the GPU ray tracing, and in here we have to do the following. So we want to do a texture bake. I do that on my GPU. I have to disable the high transparent objects. Of course, I want to see the caustics caused on the floor. Light and shadow, which is basically a full GI bake. As a first try, I stick with a preview quality just to see which effect it is causing. I want to have indirect illumination because I want to get the indirects from that green and from that red wall. I need some color bleeding, and I want to disable the override material. Otherwise, all objects will get a medium gray material, and this is not what I want. I want to have the caustics from my metal and glass material, and also I want to have the indirects from the red and the green wall. Override material is then useful if you plan to have some material variant switches. So because I get the indirects on the floor from that red wall, I'm not able to exchange the material anymore as the indirects are baked in my scene. But if that indirection is kind of medium gray, it's not that obvious that it's not fitting together, the material and the baking. So we disable that. The indirections in the moment I'm using photon mapping is irrelevant in here. This is interesting if you use path tracing. I don't have any clones, but I disable the share Lightmaps for clones. I will show you how it looks like without denoising, and I stick to the default texel density of 200 in here just to see what happens. So I select all my objects, and then I can proceed my calculation. And here we go. So I have to disable the lights in the scene, otherwise my scene is illuminated twice, once by the lights, the real-time lights in the scene, and once by the baking. So I have to disable that and use it only for the baking process itself. So, and as you can see, these caustics we have seen before in the real-time rendering are now baked. The quality isn't that good, but I want to show you the difference. So all the noise we see in here can be worked against with more image samples, and also the denoiser helps quite a lot. But overall, this is what I want to have. So let's do that again with some higher settings. So I'm using a high in here. That's fine. I activate the denoiser, and maybe I also want to have a higher texture quality. And I have to activate my lights again, obviously, for the baking. Okay, let's check the result. Disable the lights, and I think the quality of my light map is pretty good. So what looks a little bit weird are the chrome and gloss materials, as we do not have the correct reflection. So if you would turn on your ray tracer again and then go to the illumination mode and choose just pre-computed plus reflection. This is actually what we want and what we can mix. Right, so we get the lighting is baked in my scene, and the reflections are real time. So I have disabled the lights in here. So if I would enable that, again, we would get the lighting twice assigned to the scene. So you can work around that by creating a kind of fake light with an incandescence material in your OpenGL scene, so you at least get the reflection of that light. In combination with your baking and the real refractions. If you plan to do a full OpenGL scene and you disable the GPU ray tracer, another workaround would be to create your own reflection probe for it. So I have a camera in here, and let me show you first where that camera is. So there's a camera in the center of the scene. And this camera is set to spherical map, and if I would activate that and enable the ray tracer, you can see that we get that nice spherical map we can render out as an HDR and use that then afterwards in our scene as a reflection map. So I have done that already. So in my materials, I duplicated the studio environment and called it reflection, and in here I loaded my reflection HDR, which then I can assign to the nodes in my scene or to individual materials. So I can go to my chrome ball, for example, and then in the comment tab it is possible to switch from studio to reflection, and this is really nice. So I can redo that for multiple objects at the same time. So let's take all of those and then go to reflection and say apply environments to selected node. So this looks now pretty good, I think, for an OpenGL real-time scene. And what else can we do? So what you see here on that chrome ball is I lower the occlusion intensity already, but if it would be default it would look like this. And it's the same for my glass material. And usually fully reflective objects like glass objects or the chrome sphere or metal do not have a shadow. VRED does not know what to do with it in OpenGL, so we calculate we render the shadow as well, because it might be that you change the material afterwards from fully reflective to something with roughness, and here you actually would want that shadow on the sphere that is caused by that light, or basically by that cube that causes a shadow. I'm not sure what's causing it. And here you might want it, or maybe a little bit, just so you can go there. And in the common settings, you can either work with the occlusion intensity and lower that. For chrome material, you would probably go to 0. You can do that also for the other materials. Another way would be deleting it completely from the object. So in your scene, bake, light and shadow module, you can select all the objects you want to remove the shadow, very similar to the vertex-based approach. Let's take that glass prism here, and then you can say clear visible or clear all, right? that would work as well. Another option you have is to disable the shadow just for the moment, because it might be that you want to have it back at a later point. So in the Scene Graph context menu, you can go to Edit, Bake, Light and Shadow, and in here you can say use no bake, which is just disabling it, but not removing it from the node. By the way, this is also how you can switch from vertex-based approach to the texture-based approach. So if you have done both, or you have a mixture and you're not sure what to use for the moment, you can calculate shadow in both ways and decide on which objects you want to display what at one way, but you can also simply disable it here for our class material. And we do the same for that one. And I think that looks pretty good for an OpenGL scene. Right, we have some fake reflection in here. We have baked our caustics in the scene, and we get our indirections. And yeah, I think basically that's it. So thanks for watching the video. See you next time.